Hello everyone. I really appreciate your interest in this talk, and thank you for coming here. I know it's been, this conference has been for 3 days, so I promise to do my best in making this presentation interesting, and hopefully it will fulfill your expectations. I would like to start the presentation with a hypothetical scenario. Let's say you own a garden. You own a garden and, it's spring coming and you think to yourself, maybe it's high time I bought myself new shoes, new gardening shoes. So you go to your favorite e-shop, you type in the query, shoes. You look at the results, the first 12 results, and this is what you get. Now, I'm not the expert in shoe designs, but I'm pretty sure that neither of these are even remotely similar to what we wear on our feet, right? What search engines present can be a decisive factor between end-user satisfaction and end-user frustration. So therefore, the main goal of this presentation will be to show you how we went from this to this, while also sharing the lessons we learned and the challenges we faced. So my name is Martynas, and I'll be telling a story on how we tuned an e-shop or e-commerce search bar into our ally, or I should say end user's ally, with a concept which is known hybrid search. So this is the contents of the presentation. I'll start by providing the introduction and some relevant context about the client. I will also talk about what I believe is the main challenge in search and how hybrid search comes into play very naturally. What will follow will be some technical stuff and some technical details about how hybrid search works, and I will end the presentation with the showcase of results and sharing my thoughts on the experience so far and what could be the direction for the future. So, myself, I work as a data scientist at Telesoftas, which is a software development company. My main responsibility is to look for and spot potential avenues for the data to be used for innovation, and that includes foreseeing basically everything from planning, strategy, to technical implementation when it comes to data science projects. I'm joined by 2 lovely gentlemen in the team, so we are by a data analyst and a data engineer, and we together try to innovate. I previously had an opportunity, as well as privilege, to see what data science is like abroad, outside of Lithuania, both in industry and in academia. A few words about the client, or the major stakeholder that the solution was being developed for. The client is operating mainly in construction industry and e-commerce, with the former of which, and the first industry is highly specific, which really renders application of language models, out-of-the-box language models, quite challenging. And also, it is located in Germany, and therefore the main language of communication and use of the product is also non-English. So these are some facts just to bear in mind. Before I dive into details about the hybrid search, I would like to compare 2 search techniques, 2 search technologies. So we have a keyword search, which is a search technique which is based on exact matches between your search term and the search document. Where it excels is at handling industry jargon and rare keywords. And keyword search can do that especially because it doesn't care about what the words mean. What do words mean? If there is a exact match between the search term and the document is returned as relevant. However, there is a drawback, and An area where keyword search really struggles is at understanding semantic relations between the words. Therefore, it means that it can miss synonyms, it can miss important context. Consider two search phrases, milk chocolate and chocolate milk. Milk chocolate is a type of chocolate, which is, darker than white, but not as strong as dark chocolate. Whereas chocolate milk, it's actually not a chocolate at all. It's a sweetened version of milk. So to keyword search, milk chocolate and chocolate milk is identical query because it has two very same keywords. They're just swiped in order. On the other hand, semantic vector search, it understands semantic relations between the words. It capitalizes on natural language processing techniques, and it utilizes language models to produce embeddings of the text, which really encapsulate the meaning of the words and can really encode user's intent or writer's intent. However, language models and generative AI is really struggling at out-of-domain tasks, making language models very hard and challenging to use on the data that the model has not been trained on. So this really begs the question, can we create a search engine which would sort of take the best of both worlds, the green box from the keyword search and the green box from the semantic search, and would combine the adaptability of keyword search and the context awareness of semantic search? And I think you guessed it right. The answer is yes, we can, and it just happens to be the topic of today's talk, which is hybrid search. So, by the way, there is a contents tracker on the left-hand side in case you want to track the progress of the slides. Now, after we have seen several techniques for search, let's look at what a typical hybrid search pipeline looks like. So, let's say we have a document, a piece of text, a paragraph. In our case, it was a product description. At the beginning, we take it and we pass it through two different processing steps. We need to feed it into a transformer or a language model, which would produce dense embeddings. And the dense embeddings, simply put, are vectors where the essence, the gist of the text with semantic relationships is encoded. They are almost exclusively dense, meaning they do not contain zero values. And this part in the hybrid search, the transformer part with dense embeddings, is responsible for the semantic part of the hybrid search. Now, another stream or another function that we need to pass the text through is the sparse encoder. And sparse encoders produce term frequencies, which are also called sparse vectors. Here you can see a dictionary-like data structure where keys are integers representing different tokens, and the values here are their relative relevancy when taking all the corpus into consideration. Here it is represented as a dictionary, but it might very well be represented as a sparse vector with a lot of zeros, but next to in these places where the tokens were found in the description, we would have some number, some non-zero number. We would take the produced dense and sparse vectors, and we would send it into Pinecone endpoint, where the dense and sparse vectors would undergo document normalization, because these are of very different dimensions. Usually this is, in a matter of hundreds, and these are thousands. So we would need to normalize the dimensions and perform other operations that happens under the hood of Pinecone, and only then we can upsert the dense and sparse vectors into the hybrid index, which is just a fancy way of saying that it's a unit to store, serve, and do manipulations on vectors. It's like a database. Now, let's say we repeat this for all the products that we have, for all the product descriptions. We upsert every embedded form of the description in the hybrid index, and now it's time to query it. So here we have a query. It would need to go through the very same procedure, through the transformer, through the sparse encoder. We would send it into the Pinecone endpoint. It would undergo normalization, a hybrid weighting, and then we would combine the embeddings of the query with all the embeddings of the product to come up with results and to basically find out which descriptions are relevant to this query. Now, you might be asking, Martynas, what is hybrid weighting? So, this is a hybrid search, meaning it combines two different search techniques, a keyword and a semantic search. And Pinecone, or well, this specific vector database that we are using, allows us to tweak how semantic we want the search to be, or versus how keyword search we want the search to be. So really, alpha parameter controls how semantic we want the search to be, and the values of which varies between 1 and 0. And if alpha is 0, it means that we are performing keyword search, pure keyword search, completely disregarding the dense embeddings that were produced from the transformer. On the other hand, if alpha is 1, we are performing pure semantic search and completely neglecting the sparse vectors. From our experience, we have observed that alpha values between 0.2 and 0.7 works the best, because from our experience, or at least our use case, we always want at least some keyword or at least some semantic functionality. So we have seen, we know a bunch of stuff about hybrid search already, how the typical pipeline looks, what is alpha. I would like to present the tech stack that we use to implement this hybrid search. So we're using Databricks to store product data and get compute power. We write code in Python and PySpark. For product data ingestion, we use Fivetran, but of course there are options, free alternatives and open source alternatives for that. For hybrid index, we use Pinecone vector database, as already mentioned in the previous slides. But again, there are other solutions as well. Very recently, we V8 announced the support for hybrid search, Elasticsearch as well, OpenSearch, and even an open source tool for that. We took the necessary transformer from the Hugging Face, and specifically we used the multilingual MPNet base versus 2 model. We experimented with other multilingual models because we had to accommodate the need for German language, but based on our experiments, we felt that this specific model produced the best results without training. For the sparse encoder part of the hybrid search pipeline, we took the BM25 ranking function. It comes with a sort of helper package called Pinecone Text, which is created by Pinecone, it's open source, and it really helps in implementing these hybrid search systems. And finally, for model versioning and deployment, we used MLflow. So, it seems like we have everything. We sort of know how hybrid search works. We have the necessary tools for the job. So everything should be working fine, right? Well, actually, no. Even though we were obtaining the correct results, the stakeholders were satisfied with what response they get to their queries, the core issue is how long it took for us to get those responses. After deploying a hybrid search endpoint on Databricks, we experienced a very high latency, as evidenced by this line graph. The blue line indicates the median of the endpoint latency, while the teal or the light blue line indicates the 99th percentile of the latencies. And as we can see, it's very fluctuating. It can even be as high as 2.5 seconds, which is truly unacceptable in a production-like environment. The approach we took to address this was to supplement the typical hybrid search pipeline with caching. So, as you can see, we use caching to store intermediate results and not to fetch the Pinecone every time we get a request, but rather because we understand that some of the search terms are, repeated. So, sometimes people use identical search terms, so we might as well cache the results for faster retrieval. And as you can see, as evidenced by the difference in the y-axis, we have multiple orders of magnitude of improved performance. So we just saw latency, and in the table below you can see the comparison of response time statistics between a typical search engine pipeline endpoint and the cooler one. So the mean response time, the median, and the 99th percentile, the results are obvious, especially when it comes to the upper part of the distribution of the response times. It's decreased tenfold. So everything taken together, I just wanted to show you with a diagram how the hybrid search system looks like. So we have a Databricks workspace where we develop code, where we write code. We have catalogs where we store data. After we are done, we expose a hybrid search endpoint with all this functionality that was presented in the typical hybrid search pipeline slide. Now let's say a user comes to the user portal. They type in shoes, which is a search term, which is sent into the backend API. And by the way, backend API is the place where alpha is calculated, the weighting parameter is calculated based on the search term that is given. This in turn is sent to the hybrid search endpoint, and instead of sending the request to Pinecone server, we are checking the cache first, and if there is a cache hit, product IDs are returned and then consequently propagated back to the user. Now, in case there is a cache miss, none of the product IDs are returned, and it's only the time when we need to send this search term, or rather the embeddings of the search term, because all the logic happens within the endpoint. Together with alpha, we need to send them to Pinecone, and then we get the product IDs, which we use then to populate Redis and return the results. So finally, I would like to showcase you and to really prove that keyword functionality and semantic functionality is in place. So you have already seen this slide already. You have already seen the slide. We are searching for shoes, but we are getting boots. The language model interprets that as synonyms, therefore we get the results that make sense at least, instead of getting some random nonsense. Now we can also write abstract categories of tools, for example, garden tools or tools for gardening, and we would get some equipment. We can look for painting tools. We would get some marker sprays, markers, chalk, colorful adhesive tape. We can even search by use case intent. Let's say you want to compact the soil. So these are not soil compactors. These are vibrating plates. But I'm assuming somewhere in the product description, there's something said along the lines of, oh, this product can be used to apply pressure on the ground or apply pressure to the soil. And this is sort of the result of the semantic search, which is able to capture the semantic meaning and connect that vibrating plate is the right tool for the job, which is to compact the soil. So this was the semantic search, but we might very well search by specific keywords. So let's say we're searching by product ID, and we see that the very first product returned has the same ID that we requested. Searching by brand was not possible in our case with semantic search. So when we implemented a hybrid search, we can see that all the products returned are from the manufacturer that we are interested in. So, as a final slide, we were working at an intelligent hybrid search engine which is capable of handling diverse human-like requests and just in general feel more human. We can search by keywords, synonyms, or perform a use case-based search. In order to achieve this, a collaborative effort of data, backend teams, as well as business stakeholders was crucial. In the future, we have some plans of using LangChain with multiple language models to enable language agnostic search, because at the minute, it's only German that is supported. We also need to think about more intelligent ways to calculate alpha parameter, because the approach that we have right now is a little bit naive, and we might get bad results, not because the hybrid search is bad as a technique, but because we are not using it the right way, and we are not parameterizing it in a correct way. And finally, we are considering replacing proprietary search technologies with open source once they become mature enough. So thank you very much for coming to this talk. I wish you a wonderful rest of the conference and a lovely weekend. Thanks.
Thank you very much, Martynas. It's time for questions. So we have a question. What is your cache and validation strategy?
Okay, we thought about this, and we understand that the industry for which we're developing the solution is highly dependent on the season. It's very seasonal. People search for different products based on the season, and the season might dictate the search patterns. Also, we understand that we want the products to stay in cache for as long as possible. So rather than specifying the time for when the entry should be invalidated within the cache, we decided to go with a time to idle strategy to check how long an item in the cache has been idle, and if it reaches a certain threshold, it seems that it's no longer irrelevant and we can remove it.
What open source search are you considering?
What open source search?
Yes.
So from the tools that were mentioned in the slides, only OpenSearch is open source. So I checked it not too long ago, and I believe they are not yet supporting the multilingual MPNet model. They're only supporting distal use multilingual model and multilingual mini-LM model. And because we, have some good experience with that, maybe we should wait until the solution, the open source solution, becomes more mature.
Any more questions? I see there are people typing. I'm not sure.
I have a question.
Yeah.
Were you measuring somehow the effectiveness towards the user, like the business gains?
Yeah. So, to be perfectly honest, this feature has just underwent a user acceptance testing, so we are on the verge of productionalizing it, but once it's in production, we're planning to track such metrics such as conversion rates, click-through rates, etc. But based on the initial feedback that we got from the stakeholders, they're happy with the results. So, and in general, to measure the effectiveness of the language model, it can sometimes be pain in the yeah. So
so another question: are you migrating from Redis now that it's not open source?
yeah, I saw a similar question maybe a couple of days ago in the conference, and that really prompted me to look more into what is happening within the realm of Redis. So, as far as I understand, but correct me if I'm wrong, the change in the license will not have a immediate negative impact on the developers as us, but rather it's more directed towards huge enterprises who are taking Redis and open source Redis and making a lot of money out of it. So at the minute, we don't have such plans, but to be perfectly honest, I would need to maybe become more familiar with this whole situation in order to answer it confidently.
There are 3 more questions, so I guess I'll take 3 more minutes. So could you expand on how alpha parameter is calculated?
Yeah, so it's not a very sophisticated approach, and it's very it came out of this trial and error, maybe experimentation. We want alpha to be high when we want alpha to be high if we want to conduct a semantic search, because the higher the alpha, the more semanticity within the search. We're arguing that a semantic search would be a better tool for the job than the keyword search when we have multiple words within the query. So we are putting certain weights depending on the type of characters within the search term. So for example, spacebar, I don't really remember how it's calculated because, well, it was not exactly my responsibility, but they are putting weights on the type of characters, and for example, the space, which indicates multiple words, it could be indicative of multiple words present in the search term, is given a high weight, therefore it pushes the final alpha to a higher end. On the other hand, because we know that the stakeholders love searching products by ID, and for searching by ID they need a keyword search, we placed a relatively small weight on the numbers. So when the function sees a lot of numbers within the search term, we get small alpha, and basically when it sees multiple words, we get a bigger alpha.
Another question. Why did you decide not to direct query your database using your API?
Which database?
Yeah, I asked that question.
Yeah.
So I'm considering that you have a data that you want to retrieve for your search.
Yeah.
Yes. So I'm curious to know, as a backend engineer, for me, why am I supposed to go more of the data science approach in really making a query?
So what you are suggesting is to make a request directly from the backend, for example, to Pinecone?
Yeah.
So we wanted the search functionality to be the responsibility of data scientists, especially because we're planning of enhancing the system, for example, with LangChain, or who knows what will depend with it in the future. So it might be more rich in AI and more fall under the responsibilities of data scientists. So we just decided to that it will be within the scope of responsibilities of data scientists, and just use this hybrid search endpoint as a proxy to direct the request based on what search term arrives.
And the last question to close this session is quite a long one, but did you try to benchmark it with a more classical approach of recommendations? An example showing not only direct results, but selected results based on the purchase add to cart of the entered user search query.
Could you repeat the question? Well, if I understand correctly, what we are doing here is not exactly recommendations. We are doing product retrieval. Can you show it? Yeah. Oh, yeah. I think I understand the question. The short answer is no. And maybe the limiting factor for that is because we're not tracking the user session activities within the website yet, in order to be able to tell what a specific user adds to the cart, etc.